This is just a quick little video on terminology. So we have homogeneous differential equations and non-homogeneous differential equations. And these are going to become really important once we get to second order differential equations. But we wanted to highlight it here just so that you would have an idea of what this is. So here is a homogeneous differential equation, and here is a non-homogeneous differential equation. And basically, the difference is this one equals 0 and this one does not. Why is that a good thing to have this be 0, other than the fact that it's separable? They won't always be separable. But, one good thing is y equals 0 is a solution. Check that out. The derivative of 0 is 0, minus 3 times 0 is 0. Over here, if you tried to plug in y equals 0, you would get 0 equals 7e to the 3t. Not true ever, because e to the 3t is always going to be positive. Okay, so over here, y equals 0 is not a solution. Okay, can often be advantageous for y equals 0 to be a solution. The other good thing about homogeneous differential equations is if y of t is a solution, then some constant times y of t is also a solution. Check that out. You found some y that satisfies this. Let's just plug in k times y. Okay, you get the derivative of k times y with respect to t minus 3k times y equals 0. Okay, we don't know if it equals 0. So the left-hand side is this. Okay, well then that is, constants don't matter, right? I can pull this out. So k dy by dt minus 3ky, but now I can factor out a k from everything. K dy by dt minus 3y. Okay, but now this is the original, which equals 0. So I can sub in 0. This is actually k times 0. So the left-hand side is 0. So by guessing and checking, basically, I can check that if y of t is a solution, then k y of t is also a solution. This is not true here. If y of t is a solution, it doesn't necessarily mean k y of t is a solution. You can just see that. The left-hand side is the same. You would work out all the same stuff. You would end up with k times dy by dt minus 3y. This is what the left-hand side is. But then, instead of plugging in 0, because over here we had that thing in the parentheses was 0, now this thing in the parentheses is 7e to the 3t. Okay, so the left-hand side is going to be k times 7e to the 3t, and the right-hand side is 7e to the 3t. So over here we had the left-hand side eventually equaled the right-hand side. Here it does not equal the right-hand side. So it is not true that if y of t is a solution, then I can just multiply by any constant. Okay, these are both advantageous properties that are true of homogeneous equations, not true of non-homogeneous equations. And we'll look at this concept again when we solve second-order differential equations in general.